Hi, hello, welcome back to our channel. Today I want to share with you very important long answer for second year physics exam. So I want to share with you that how you can solve the Doppler effect in easy way. There are different methods are there. I hope it is very useful for you. Look here, come to our topic. What is the Doppler effect? The apparent change in the frequency due to relative motion between the source and observer is called what? Doppler effect. When you are standing on the platform, train is moving towards you. That sound, you can observe more sound. Why? Frequency is more. Same train is leaving from you. We are observing slowly the frequency is decreasing. Sound is decreasing. So this type of apparent change in frequency due to what? Either you are moving towards the train or train is moving towards you, and both are moving away from each other. We should observe this one. This is called the Doppler effect. Finally, you can view that the apparent change in the frequency due to relative motion between the source and observer is called the Doppler effect. So in this first case we are taking when source moves towards the stationary observer. This is the source, this is the observer, and clearly we are taking observer is at rest condition and source is moving towards the observer. What about that frequency? We have to find out. Simple thing, you are there, you are observer, and I am the source and I am moving towards you. First I am standing here, I am speaking with you, the sound waves are reached to you. How much time it will take? See, let n be the frequency of the source of sound. It emits the sound waves with speed how much? V. In regular intervals of time, t equals to 1 by n. So when I am speaking with you, first wave is reached to you. How much time it will take? Distance between the observer and source is L. And time is how much? T1 equals to L by V. Here V is the speed of the sound. Now what happens in second case? The source is moving S to S dash. How much time it takes? T is the time. But distance is how much? Velocity of source into time. And as usual, this is the velocity of the speed. Don't confuse here. Vst is the distance between S and S dash. Vs belongs to speed of the source and T belongs to how much time it will take. Then now at present, what is the distance between S dash and O? That is the L minus Vs into T. Now we have to go through the second sound wave, at what time it will reach. So at t equals to t seconds, the source emits second sound wave reaches the point observer at t2 we are taking. See, this point only very important. Here t2 equals to t plus. We are moving from S to S dash. T plus, and now the at present distance is how much? L minus Vs into T. But we don't want distance, we want the time. That's why L minus Vs into T by speed of the sound. This is very important. T plus, we are moving from S to S dash, and one more time, how much time? From S to S dash to O. That is the L minus Vs by T by V. After simplification, now we want the time interval between them. Second wave, second sound wave and first sound wave. That's why we are doing T2 minus T1. This is the T2, T plus, just I split that L by V minus Vs by Vs T by V minus T1 is the L by V. Here L by V will cancel together. In this T dash equals to T minus, we are getting T minus Vs into T by V. After that T is the common. When we are taking T is common, 1 minus Vs by V. Then n dash equals to 1 by T dash. Then n dash equals to 1 by T into V by V minus Vs into this one. So here when the source is moving towards the observer, what happens? We are getting the more frequency. That's why apparent frequency is greater than original frequency. In second case, source is moving away from the stationary observer. So in this case, what we are taking, simply we can take the sign change of this denominator. So n dash equals to n into V by V plus Vs. So apparent frequency is less than original frequency. I am repeating this. The relative motion between the source and observer is called the Doppler effect. In this we are going to discuss two cases. In case 1, the source is moving towards the stationary observer. So speed of the source is Vs, speed of the sound is how much? V. The distance between stationary observer and source is the L. In first case, the source is at S, it is giving the sound, how much time it will take to reach you? T1 equals to distance by v, speed of the sound wave. Then in second case, we are moving from S to S dash. The source is moving from S to S dash. It takes time t, and how much time total sound is reached to the stationary observer means we can take t plus distance. Here we don't know about the time. That's why distance by speed we are taking. Distance is the L minus Vs into t by v. So now we know the T2 and T1. We can go through the time interval. Here time interval between two successive sound waves, it is nothing but time period only. So T dash equals to T2 minus T1. Here instead of T2 we are taking T plus L by V minus Vst by V. Minus T1 means L by V. L by V cancel. We are taking the common T. So T equal to 1 minus Vs by V. Now we know this time interval, but we want the frequency. What is the relation between frequency and time period? N dash equals to reciprocal of the time period. N dash equals to 1 by T dash. So 1 by T, this is 1 by T into, this is 1 by 1 minus Vs by V means this denominator is coming as a numerator, V by V minus Vs. Instead of 1 by T, we are taking frequency of that source, original frequency. This is apparent frequency, this is original frequency, and it is V by V minus Vs. So here apparent frequency is greater than original frequency. Like that case 2, when the source is moving away from the stationary observer, just you can change the sign convention, V by V plus Vs into N. Here apparent frequency is less than. Thank you everyone. Please subscribe my channel and share this video to your friends also. And more long answers already I have made. Go to playlist and look that second year long answer questions. All you will get it. Almost all I have made that one. Few answers I will do in few days also. Thank you everyone.